Okay, so all I have to do is simplify my numerator. I get 19x minus 8x is 11x minus 9 all over 5x minus 1. I can't simplify this any further. It's my answer. Number 2, my common denominator. I don't even care if it's the least common denominator anymore. Just get a common denominator. My common denominator here is x times x minus 7. So basically what I'm going to do is multiply this numerator by that denominator, multiply this numerator by that denominator. So that's exactly what I have set up here. 5 times x minus 7 plus 4 times x all over my common denominator, x times x minus 7. All I have to do is multiply it out, simplify my numerator. Okay, distribute. 5 times x is 5x. 5 times negative 7, negative 35, plus 4x. All over my common denominator, x times x minus 7. Simplify my numerator. 5x plus 4x is 9x minus 35 all over x times x minus 7. Double check to make sure you can't factor and cancel something out. Okay. Pardon me? Well, all the B's.
There's a website, if you type in like rational fraction calculator, like for practice, it'll like put it in and it walks you through each step. Yeah, no, not.
There's several of them.
Yeah, like
so
you type it in and it'll like tell you exactly what each step is.
Yeah, the problem is students will go to something like Photomath and just get the answer and they won't get that step-by-step process.
Photomath doesn't do that. Why are you pointing at us? It worked first semester, but it doesn't work this semester.
It doesn't, Photomath won't work on probabilities, or I don't think it works on rational expressions.
You like it's a calculator and it's specifically designed for that.
Yeah.
You like type in specifically what it is, so there's no room for error.
Good. Okay, 3A. 3A, I have a common denominator already, and that's x minus 5. So all I have to do is simplify this numerator, 9x squared minus 45x. Well, I can factor out a 9x, and I get x minus 5 all over x minus 5. Now I have a common factor I can cancel. And I get 9x. So that's my answer. It's supposed to be 80 next week. Okay, 4A. I have an expression again. I'm going to come up with my common denominator. Again, I only have the two fractions, so I'm going to multiply my common denominator is this quantity times this quantity, which I got here. So I'm going to take my 5, multiply it by this x plus 2, and the x times 3x minus 1. Be careful. You have to distribute the negative x. Okay, so I get 5x, because I have to distribute that, plus 10 minus 3x squared plus x all over. Don't multiply this out. Leave it factored. 3x minus 1, x plus 2. Let's work a little bit on this numerator. Okay, I'm gonna put it in standard form first. Negative 3x squared. I have a plus 5x and a plus x gives me plus 6x. And plus 10. All over 3x minus 1, x plus 2. Now, we're going to have to check this numerator out, see if it doesn't factor and cancel down. First thing I'm going to do is factor out that minus sign, because it bothers me. So I have a negative 1 times 3x squared minus 6x minus 10. Okay. See if I can factor this. I'm factoring out a negative because I have a negative in my leading coefficient. Okay, so I took out that negative 1, which just changes the signs. So now I'm going to try factoring out this 3x squared minus 6x minus 10. So I have a 3x and an x. Now I've got a 3x here. I'm going to see if there's a minus 1 there. Just going to see if a minus 1 will work there. If I put a 10 there, nope, that's not going to work. How about a 2 and 5 gives me, nope, that's not going to work. How about a 5, 15, and 2, nope, it's not going to factor. So I'm good to go. Always make sure you at least try to factor that quadratic out. I don't know why you guys had so many problems with when we get to equations. Whenever you see the word solve, you know you have to get x by itself. Okay, it means you have to, whenever you have an equal sign, you have to solve. Get x by itself. Now, since, you know, it was nice and quiet when you weren't here. I hate to say it. It really was. For real. I know. I know, but it really was quiet when you weren't here. I can't have 0 in the denominator. If one of these fractions becomes 0, then I'm done. Okay, because it's undefined. So what I do is, first thing, factor everything and set all the factors equal to 0. I have x plus 7 equals 0, and I have x minus 7 equals 0. Here, x equals negative 7. Here, x equals positive 7. These numbers will make my denominator 0. So I have to exclude them. X cannot equal plus or minus 7. This is a really easy question that a lot of you guys have a tendency to, well, not this class, the other classes I teach. About half of the class miss that. Factor, set each factor equal to 0. Okay, page 2. Now, we have rational equations, so we're going to have to solve for x. Again, you might as well look to see, you might as well look to see what makes our denominator 0. Well, this is pretty easy. 0 times 2 and 0 times 2, so x can't equal 0. What about this one? X cannot equal negative 1 because negative 1 plus 1 would be 0. So these are our excluded values. When we solve this, you get x equals a number. If it's 0 or negative 1, there's no solution to the problem. Alright, so what I'm going to do is take a common denominator, and all I did was look at these. This has a 2x, this has a 2x, this has an x plus 1. So I need at least one 2x and the x plus 1. So I'm going to actually distribute this to each one of the terms. I have to multiply to each term. So I have 2x times x plus 1, 3 terms. I'm going to have to multiply it to all 3 terms. I know this is a pain writing it out like this, but it seems to help students make less mistakes. Okay? So my first term, 7 over 2x, I'm going to multiply it by 2x times x plus 1. So my 2x is going to cancel out, and I get 7 times x plus 1. Now, remember, the whole idea here is to get rid of the fractions. So that's 7 times x plus 1 equals, and then I have my common denominator, 2x x plus 1, times my second term, 6 over 2x. My 2x's cancel out, and I have 6 times x plus 1. 6 times x plus 1. And then I'm going to take my common denominator, multiply it by the third term. This time, my x plus 1's cancel, and I get 3 times 2x. It's a plus sign. So I have 6x. You with me? Okay. This becomes, what, a 2-3 step simple algebra 1 problem. Distribute the 7, 7x plus 7 equals distribute the 6, 6x plus 6 plus 6x. Combine like terms, 7x plus 7 equals 12x plus 6. I'm going to bring the 6 over here. That gives me 1. And minus the 7x over here gives me 5x. So 1/5 is going to equal x. And I'm good because it's not 0 or negative 1. That's my solution. These problems had a lot going on. What? This whole course, I'm not doing it points per problem. I'm doing it how many conceptual errors you're making per section. Okay, this is rational. This would be one section, solving rational equations. Okay, so if you had one concept wrong, even every problem could be wrong. If it's the same concept, you only get 1 point off. If it's multiple concepts, well, then you only get 2 out of 4, which is 50%. Make sense? If you leave it blank, it's a 0. Zeros are hard to come back from. All right, 8a. I have 3 over x plus 1 plus 1 over x squared plus 1, that can be factored to x times x plus 1, equals 4 over x squared plus x, which can be factored to x plus 1. So what's my common multiple here? Well, here's an x plus 1, here's an x and an x plus 1, an x and an x plus 1. So I have to have at least x plus 1 and an x for over here. Kayla, this is, I think, where you start getting confused. I have to multiply each term by x times x plus 1. So, here's my first term, 3 over x plus 1, 3 over x plus 1. I have to multiply it by x times x plus 1. Plus, my second term is 1 over, and I'm going to put my factored form there, 1 over x times x plus 1 equals my 4 over x plus 1. Here's my 4 equals 4 over x plus 1. And I'm multiplying it by my common multiple, each term. Okay. Let's cancel out. This one has x plus 1, this one has x plus 1. Leaves me with 3x. Here, x plus 1 cancels, x plus 1 cancels, my x cancels, my x cancels. It's just all 1 times 1, which is 1, equals, same thing here. The entire thing cancels, leaves me all with 1s. 1 times 4 is just 4. What's x? Okay, what's my extraneous solutions here? What can x not equal? Well, go back up here. Can't equal -1 here, because that would give me a 0. Can't equal 0 here, because that would give me a 0. Same with that. So am I good with my solution? Yeah. Can't be -1 or 0. I'll get there. Hang on. This is a give me. Number 9a is a gimme. That's an easy point. I have a fraction equal a fraction. What can I use? Think back in 8th grade. A ratio equals a ratio. It's a proportion, right? It's a cross multiplying cell. So 1 times 2x plus 3, 1 times 2x plus 3, and 2 times equals 2 times 5x plus 4. 10x minus 8 equals 2x plus 3. Subtract 2x, I get 8x minus 8 equals 3. Add 8, 8x equals 11, so x equals 11/8. But you still have to watch for extraneous solutions. Okay? Here I'm going to have 4/5. Here I'm going to have -3/2. We're good. ¿Comprendes? Okay, number 10. 10a. I put the fractions in here. Working alone, Betty can finish the homework in 3 hours. So her rate, 1 job in 3 hours. Working alone, Jackie can finish the job, same homework in 2 hours. So 1 job, 2 hours. How long will it take them to finish the homework? So we're trying to figure out the time if they work together. Oh, yes, it would be cheating. So this part of the job plus this part of the job equals the whole job. So my equation, I have x over 3 plus x over 2 equals 1. Now I have to multiply this by the common denominator, 6. Just multiply these two together. 6 times x over 3. Well, 3 goes into 6 twice. 2 times x is 2x. 6, let's see, 2 goes into 6 3 times. 3 times x is 3x. Please don't forget to multiply the 1 by 6. X equals 6. X equals 6/5. The hard part's setting them up. Questions, comments, concerns? 11A. Working alone, Joy can create the final exam in 4 hours. So, one job in 4 hours. When Joy and Sal work together, they can write the exam in 1.7 hours. So this time they give us the time. Together, 1.71. 1.71. How long will it take Sal to write the exam by himself? So we don't know his rate. Okay? Multiply these together. See, 1/4 times 1.71 is 1.71 over 4. 1 over x times 1.71 is 1.71 over x. Add these together, they equal 1. So I have 1.71 over 4 plus 1.71 over x equals 1. What's my common denominator? 4 times x. 4x. 4's cancel. I get 1.71 times x plus, this time my x cancels, so I get 4 times 1.71. Please don't forget to multiply the 1 by 4x. Okay, what's 4 times 1.71? I don't know. 1.71x, let's see, 4, 28, 2, or 6.18, 6.84, maybe. Let's say I'm going to subtract 1.71 from both sides, so I get 6.84 equals, 2.29. See, I told you. Divide both sides by 2.29. What does x equal? 2.9. So you can do it in about 3 hours. Your final's coming out. When do you use permutations? Let's see, when you line up. Arrange, I think, was another one, right? Arag, I think I put. And range, line up. I can't remember the last one. How about combination? Group, useless committee, team. How many ways can you arrange, so it's going to be a permutation, 6 students at the door in a line? You can use either one. You can use a counting principle, or you can use permutation. I would use permutation because of that key word. How many? Your total is 6. You have 6 choices. 6 factorial is 30, 120, 360, 720. And 13A, how many meals can you create if you have 5? When you have something like this, use fundamental counting principle. 5 times 6 times 4. Okay. 12B. How many ways can you, here's team, so what am I going to use? Combination. My total goes first, 35. Choices go second. Okay, everybody remember how to put this in your calculator? Not combination. Combination's got a word formula. Is it really? Let's see, 35. Hit the math, go to prob, and hit the combination. And 6. And enter. Ooh, it is a really big number. It's like a million different ways. Okay. Any other questions? 13B. How many schedules can you create if you must choose from a category of 5 science classes, 4 math classes, and 5? Yeah, it's the same thing. I would use the counting principle. 5 times 4 times 4. You could use permutations, but then you're going to have to multiply the permutation. It's just easier to do counting principle. You guys going to do good tomorrow? I'll have the quizzes on the desk. Start working on them right away. Because it's... Oh, is there another sheet? Oh my gosh. I'm going to have to do this fast. Yes, it's pretty long. Let's just do these real quick. Describe a situation in school that would require a survey. How would you distribute? When you distribute the surveys, say we want a choice of better food, okay? That would be a survey. Choice of foods. Okay, so we're going to start a survey. You want pizza or hot dogs or something like that. Okay, when you distribute or collect data, make sure it's randomized and unbiased. Okay, say computer generated. Okay, that would be completely random. Because a computer can't, be biased. In fact, that would even take care of your bias too. This is an excellent answer for keeping things randomized. Student list. Okay? That would be completely random and unbiased. For a statistics project, a group of students wanted to know how many students intend to get summer jobs. They decided to give out a survey to a random sample of students. How could they distribute this so the results are random? And again, computer generated list. Easy. Also give an example of distributing the survey and getting biased results. Picking students that, always buy hot dogs. Okay. Calculating. The important thing here, your total conditional probability, your total's always going to be the denominators. 128, 128, except for that word given. That becomes your new denominator. Given male. Well, where's our males? 68. Okay. 128. 128. Here's a given. Underweight. 30. Because I got to go down. Alright, so we want normal weight and female. So here's normal weight and female. Because we got the word and, we need the intersection, right? What's our intersection of normal weight and female? Normal weight, 14, right? Just leave it. Don't reduce, don't do anything. How about male or underweight? Okay, that's a union. So male, 68, right? 68 plus underweight, 30. But what happened here? Didn't we count that 5 twice? The 5 we counted twice, so we're going to have to subtract that 5. With me? So I have 98 minus 5, 93. 93 over 128. Yes? Okay. I'm going to use a highlight to mess it up because it's really important. Okay, it says either males, so here's my males. 68, right? That's my total males. Or underweight. My total underweight is 30. So 68 plus 30. But look what happened to the 5. It got counted twice, didn't it? So I have to take one of those 5s out. Okay? Of the given males, how many are normal? Here's my males, 18. Given the underweight, how many are males? Here's my underweight, here's the males, 5. Female, let's see, female, I have 60. It's another one of these, got to watch if I'm going to count things twice. 60, normal weight, 14. I'm sorry, normal weight's 32. Sorry. So I got 60 females, normal weight 32, but I counted 14 twice. So I have to subtract 14. Yes. Because I counted it twice, I only need to count it once. So I have to subtract 114 out. Okay? So I have 92, 82, 78. And overweight and female.
But technically, you could get it without putting it up.
Overweight, 60. Here's my overweight and female, 21. What? No, you can't ignore it with an or. Usually you have to subtract something out because it's counted twice.